Welcome to class number 14. In this class, we're going to cover sections 7.3 and 7.4. This is the second part of benefit cost analysis. Again, I refer you to the schedule of assignments on the bottom of the start page in Blackboard. You should read pages 2005 through 205 to 212. This instructor video will be posted in the module number 7, and I'll do in this video. I will present some lecture notes. I'm also going to work some end of chapter problems, and then there'll be another video with some homework problems. If you really want to be successful in the course, you should work as many end of chapter problems as you can, as time permits you to do that. Section 7.3 deals with what's called a profitability index, PI, and it's another way to look at public service projects. The profitability index is defined as the annual worth of the benefits minus the cost divided by the initial investment's annual worth. Okay, so everything has to be annual worth. Again, since it's a ratio, if you use present worths, that's okay, as long as you use the present worth of both the cost, the benefits cost and initial investment, and so on. So that is equation 7.4. I'm going to discuss a couple of example problems for you, and then we will in fact go on to work some homework problems. So the author gives as example 7.3 in your textbook this problem. You can invest in your brother's public service project. Your brother apparently is going to build a toll road, okay, with the following estimates, okay. Now, this thing here, symbol, in your textbook means it's kind of a personal finance type of problem. Well, it could be anybody's problem. It could be a corporation or most likely a public service project. But anyway, it says if you invest $90,000 now, so that's a cost, and you also have to invest an additional $5,000 a year annual contribution. So that means that you're helping them pick up the maintenance and operating costs of this toll road. However, your revenue will be $20,000 the first year, and it'll increase by $4,000 a year, and you have a 5-year planning horizon. So the question is, determine the values using the profitability index. Determine 3 values using the profitability index to evaluate this project with different MAR values. So in part A, we use a MAR of 8%. In part B, we just assume a 0% MAR, okay? And then in part C, we actually find the rate of return. Well, we're not going to do part C by rate of return. We've already looked at that. I didn't really teach the goal-seek method in Excel, although you can certainly learn it on your own. You can see how it's done. It's a pretty powerful tool for solving equations, and that's really all you're doing. Remember, the rate of return equation is just to set the present worth equal to 0 and solve that equation. It takes some work to do that by trial and error, as you saw, but this goal seek will do it for you as well. So first we're going to solve part A, rate MAR of 8%. So we're going to find the profitability index at 8%. And remember, the profitability index, the equation 11.4 is what we need to use. And it's the benefits minus the cost divided by the initial investment. And we usually work that with an annual worth method. So the annual worth of the initial investment of $90,000 is 90,000 times A given P, 8% for 5 years. And that turns out to be $22,541. And we also, don't forget, have an additional $5,000 annual cost. So that has to be added to that to get our total annual cost. The annual revenue is $20,000 the first year, and then it goes up. So it's a arithmetic gradient series. So we take the $4,000 that it increases each year times A given G, 8% for 5 years. If we do that calculation, we get $27,386. And so we add the $5,000 to the 22. We subtract the $5,000 from the $22,000 that is the benefit minus the cost, and divide that by the initial cost, which is the $22,000, and we get 0.99. So it doesn't quite make 8%, just short. So let's review again what we're doing here. We've got the annual worth of the benefits minus the cost divided by the annual worth of the initial investment. Okay, so we have an initial investment cost of $90,000 A given P, that's $22,541 per year for 5 years. So that's going to be our denominator. The numerator will be our revenue minus cost annually, okay? And so we get $27,386 in revenue minus that $5,000 in cost. It gives us dollars per year here, dollars per year here. When we divide that, we just get a ratio 0.99. Okay. Now, the second part of the question, part B, which is the last part we'll solve, says if you use 0%, would this be a good investment? Well, recall that, for example, A given P, 0% in 5 years would just be 1 divided by 5. It would just spread the 90,000 evenly at 1/5 a year. So it'd be 1/5 of 90,000, which is 18,000. And that's going to be your denominator, okay, of the annual worth equation. And then your numerator is going to be the revenue minus the cost. Well, the revenue is 20,000 the first year, 24,000 the second year, and you keep going on up. If you add them all up, the total revenue divided by 5, because the interest rate's 0, you simply get $28,000. And then you have the $5,000 annual cost, so you get 28,000 minus 5 is 23, divided by 18 gives you a ratio 1.28. So at 0%, yes, it's a good investment. We sort of knew that anyway, because this was very close to 8%, because this was 0.99. In fact, if you do go and solve this for using GoldSeek or just using trial and error method, you're going to get a number pretty close to 8%, 7.9 or so for the rate of return on this investment. The next section of the course is section 7.4, and it deals with incremental benefit cost analysis of two or more alternatives. Recall, when we did rate of return, we did, when we had more than one investment, we had to use an incremental approach because rate of return didn't work, so to speak, by just getting the investment with the largest rate of return. So if you have a set of mutually exclusive alternatives, in other words, you can do none or just one, not more than one, then you use this incremental approach, even with the benefit cost analysis. So the author describes in this slide two possible cases, and one is where your benefit is really not a direct benefit, but it's a usage cost. It's a difference in the usage cost between the two alternatives. And the other case is where you have a direct benefit. Remember, when we did rate of return, we had the situation where there was no revenue or only a salvage value. In that case, we didn't consider the do-nothing alternative. We only considered do-nothing when there was revenue, okay, annual revenue. Similarly, in the benefit cost incremental approach, we only consider the do-nothing when there are direct benefits, not just the difference in cost. So if there's only a difference in usage cost, then we don't consider the do-nothing alternative. If there are direct benefits, we do consider the do-nothing alternative. So I'm going to look at an example problem now that the author presents in section 7.4, and he first goes through the steps. These steps are exactly analogous to the steps we went through with rate of return. Not exactly the same, but analogous to. The first step is to determine the present worth, annual worth, or future worth of the cost, C, and the benefits, B. So we decide, are we going to use present worth, annual worth, or future worth? And then once we do that, we get the present worth of the cost and benefits. And the disbenefits, if there are some, they come off of the benefits. So we really work with net benefits, benefits minus disbenefits in the numerator, okay? And then we order the alternatives, increasing total equivalent cost. And that's for the direct benefits. We add in the do-nothing alternative, okay? So the next thing we do is order our alternatives. And of course, the first alternative will be the do-nothing because it doesn't cost anything. So then we compare do-nothing with the next or the lowest costing alternative. We select the best one of those two and compare and go on, and that's steps 3, 4, and 5 until we've done them all, and then whatever we ended up with as a survivor in the last step, that's the one we pick. So let's employ this procedure on an example problem. All the alternatives have an equal life of 30 years. The interest rate is 5%. This is a direct benefit alternative because it says patients benefit from design 1, $800,000 a year, and from design 2, $1,050,000 a year. Okay, and so let me focus in on this one a little bit more. Maybe you can see it better. The design 1 cost $10 million, and has an annual maintenance cost of $35,000, but benefits of $800,000. Design 2 has construction cost of $15 million, annual maintenance and operating of $55,000, but it results in more benefits, $1,050,000. Of course, the do nothing alternative, we could put that one there. That costs nothing, has no maintenance cost, and has no benefits. So we're going to compare design 1 with doing nothing, okay, because we have direct benefits. So we're going to work with annual worth because this is a present worth, but these two are annual worth. So we convert the $10 million A given P 5% for 30 years to a uniform series, and then add in our $35 M&O to get our total annual cost, and that of alternative 1, that's $685,000. The total annual cost of alternative 2 is $15 million A given P, plus $55,000 A given P 5% for 30 years. That turns out to be $1,030,000 and $750. So step 2 is to order the alternatives according to the cost. Alternative 1 has an annual cost of $685,000 to $1,030,750. So this is going to be the one. Alternative 1 will be compared with doing nothing, because this number here, which is the total annual cost, is less than total annual cost of 2. And of course the cost of doing nothing and the benefit of doing nothing is 0 and 0. And so really this is just going to be the BC of design 1. So that will be done in the next slide. So the delta BC, and this is 1 minus do nothing, okay? That delta BC is just the benefits of 1, which are $800,000 a year, divided by the cost of 1. Really, it's really 800,000 minus 0 divided by 685,000 and 500. That's the cost, minus 0. So we get that equal to 1.17. And consequently, we select 1 rather than doing nothing, because the benefit cost ratio is greater than 1. So we do that. So the next step is to compare 2 with 1. Okay, when we do that, the difference in benefits, 2 has a benefit of $1,050,000. 1 has a benefit of $800,000. So the difference, the delta benefits, is $250,000. The delta cost is $1,030,750 minus $685,500, which gives me $345,250. So when I do that delta, this is the delta of 2 minus 1, I get 0.72. And that's less than 0, so we eliminate the higher costing alternative 2. 1 is the survivor, so that's our selected design. Now, the author introduced some other stuff with this example problem in the text, and I'm not going to cover that because I don't think it's really relevant or even correct. So I'm going to go on and work some homework problems next. This particular homework problem is problem 710 at the back of the book, at the back of the chapter. And so let's start and read the problem. They want you to calculate the benefit cost ratio for Part A. Part B, calculate the modified benefit cost ratio. And then Part C, calculate the profitability index. And we're given that the discount rate, which is our I, the interest rate, 10% per year, and it's compounded annually. And we're also given that the life of these, the projects is 20 years. And we want to look at this project and calculate the benefit cost ratio. And in Part A, at least. Part A, B, C. Okay? So we have a present worth of present worth of the benefits of $3.8 million, and then the annual worth of the disbursements, disbenefits is $45,000 per year. Be careful of the units. This is dollars because it's a present worth. This is dollars per year for 20 years because it's an annualized number. The first cost, that's the investment cost. So we got the benefits. Now we're getting the cost is $1.2 million. And the M&O cost per year, $300,000, 20 years. Okay, so we want to get, we could work this with annual worth or with present worth. I'm going to go with annual worth. So the annual worth of the benefits will be, of course, the annual worth of the benefits minus the disbenefits. So this will be 3.8 million written out here, 3,800,000, A given P, 10% for 20 years. So this is going to be dollars per year now. This is dollars per year. And this is dollars per year for years 1 through 20. Years 1 through 20. So I can add or subtract those. So I'm going to subtract the 45,000 because that's a disbenefit. And if I crank through this number, the annual worth of the benefits will be this times this turns out to be $446,347, and that was using the app. It'll be a little bit different if you use the tables because we're dealing with really big numbers and the app carries more decimal places than the tables can. So, and then we subtract from this the 45,000 in disbenefits to get our annual net benefits of $401,347 per year, years 1 through 20. Okay. So now we have our benefits. That's our numerator. We need to do the cost. The annual worth of the cost, and we have an initial cost of 1.2 million, 1,200,000 times A given P, 10% for 20 years. That will become dollars per year now for 20 years, years 1 through 20. We have an M&O cost, which is also a cost, so we'll add that, 300,000, and that's dollars per year as well. So when we calculate this 1.2 million times A given P, we get $140,951, and then we add to that the $300,000, and both of those are dollars per year. When we add those, we get $340,951 per year, and that's for years 1 through 20 as well. So now we have our benefits and we have our cost, and we're going to do, I'm sorry, this is 440,000, 300,000 plus 140,000. So that makes a big difference because that's going to change the ratio, of course. So the BC is actually the annual worth of the benefits divided by the annual worth of the cost is equal to 401,347 divided by 440,951. If you do that division, you get 0.91, which is less than 1. So do not do the project. Or another way to put that is it's not economically justified. Okay, so that concludes problem 7.1. We're going to work one more problem. By the way, I have the answer to this typed out for you as well. In the typed version, I used the tables, so the numbers might be just slightly different, oh, we're not finished with this problem. It's a good point. That's only part A. We need to do parts B and C. Part B is to find the modified BC ratio. Well, recall the modified BC ratio, so this will be part B. Find modified BC. Okay, to do that, the denominator can only contain the initial cost. So that means that this M&O cost goes up into the numerator, and it's treated similarly to how you would treat a disbenefit. Okay, so it's an M&O cost, but since the modified BC method can only take the first cost in the denominator, so in that case, then in the numerator, we put the M&O cost as a negative. So if we look at what we had, so our BC would be the annual worth of the benefits minus the disbenefits minus the M&O cost. And then in the denominator, we'll just have only the annual worth of the initial cost. So that's the modified method of BC. And generally speaking, it does not change the decision. Okay, so if this ratio is less than 1, we expect this one to be less than 1. Okay, so let's look at the annual worth of the benefits minus disbenefits minus M&O. Well, remember our benefits was 3.8 million times A given P, and the disbenefits was 45. So we ended up with this product here was 446,347 minus the 45. So we'll put that here. BC will be equal to, we'll put this and this, 446,347 minus 45. And now we're going to take this 300,000 that was in the denominator here, and we're going to move it up to the numerator as a negative benefit. That M&O cost minus 300,000, then we'll just divide this by the initial cost. Well, the initial cost spread over the 20 years turned out to be 1.2 million A given P, 10% for 20 years was 140,951. And if you do this math, then you're going to get this 401,347 minus 300,000. That'll leave you with 101,347 over 140,951, which is equal to 0.72, which is also less than 0, and so do not do the project. Now, the part C of this question was to do the profitability index. That's way back there. Well, let's see. Part C, the profitability index for the cash flow. Okay, profitability index. So let's do that part C next. The first thing I want to say is the author tells us in the book under profitability index that in this method we disregard the disbenefits. They're not considered. So that $45,000 of disbenefits, not going to be considered. And the profitability index is then in the denominator you only use the initial costs, similarly to the way we did the modified benefit cost ratio. So the PI then will be the annual worth of the benefits minus the M&O divided by the annual worth of the initial cost. So the key to this is disregard the disbenefits, don't consider them. So the annual worth of the benefits minus the M&O would be this 346,000 minus the 300,000, but not minus the 45,000. So we'd have 446,347 minus 300,000. Divide that by the same denominator we had for the modified, 140,951. And now we are going to get, if we subtract the 300 from the 446, we're going to get 146,347 over 140,951, which you can see that's greater than 1. In fact, it's equal to 1.04. So since the profitability index is greater than 1, this says do the project. Of course, the reason we're doing it is because we're not considering the disbenefits, and that's the difference in that. So from this point, I'm going to go on to one more homework problem. This is problem number 23 in chapter 7, of course. And the problem reads as follows. The Logan Well Services Group is considering 2 sites for storage and recovery of reclaimed water. The Mountain site will use injection wells that cost $4.2 million to develop and $280,000 per year maintenance and operating costs. This site will be able to accommodate 150 million gallons per year. The Valley site, okay, will involve recharge basins that cost $11 million. So you can see the Valley site is much more expensive initially, at least, to construct, and $400,000 to operate and maintain. So it has both larger initial costs, larger M&O costs. At this site, 890 million gallons can be injected each year. So it will has a capacity much larger than the 150 of the mountain site. The Valley site is bigger, costs more, has larger capacity. If the value of the injected water is $3 per 1,000 gallons, okay, which alternative, if either, should be selected according to the BC ratio method? Use an interest rate of 8% and a study period of 20 years. So I is 8, N is 20. And we're going to look at the data. We have direct benefits because the gallons, the value of the water, the injected water, is $3 per 1,000 gallons. So the benefit of these two alternatives is a number that's the dollars per 1,000 gallons times the number of gallons in thousands will give us a $1 benefit. So since we have a benefit, our first alternative, a direct benefit, our first alternative is do nothing. The second alternative will be the next lower costing one, which will be the mountain site, MS. And the third will be the highest costing one, is the Valley site. So we're going to compare the mountain site with the do nothing site. Of course, do nothing is just all zero, so we're really just going to look at the mountain site and see if its benefit cost ratio is greater than 1. So let's go to the benefits first of all. The annual worth of the benefits of the Valley site minus do nothing. So we'll start with the annual worth of the Valley site. Well, there's 150 million gallons that can be processed in that site. That's gallons per year. We're going to multiply that by $3 per 1,000 gallons. So we can divide this 1,000 into the 150 million. We're going to end up with 150,000, and then we'll multiply times 3, which will give us 450,000. These gallons will divide out this gallons, and remember this was, I'm sorry, we don't have a dollars there. This is dollars per year now. So this is going to be $450,000 per year, and that's for years 1 through 20. So that's the annual worth of the benefits of the Valley site. Now, the Valley site minus do nothing is the same number because do nothing is 0. Okay, but we'll next do the annual cost, annual worth of the cost of the Valley site. The Valley site costs $4.2 million to develop and has an M&O of $280,000. I'm sorry, this is the mountain site. Did I get them wrong? Yeah, this is the mountain site. So the annual cost of the mountain site is the lower costing site, is 4.2 million. So I need to spread that over A given P, 8% for 20 years, and then add the 200, and this is going to be dollars per year, by the way, once I multiplied by A given P, 280,000, and that's going to be dollars per year as well. So I can add those two. So if I take this 4.2 million and multiply it by A given P, 8% for 20 years, doing that on my app, I get $427,779 per year. And then I have the 280 that I need to add to that. And that's dollars per year. And so the sum of those two turns out to be $707,779 per year for years 1 through 20. So now I have the benefits of the mountain site and the cost. Well, the delta between that and the do nothing alternative, so I'll get delta BC will be this number minus 0. That's the benefit of the mountain site minus the do nothing benefit. Divide that by the cost of the mountain site, 707,779, minus the cost of do nothing will simply just give me 450 over 707. And when I do that, of course, I get something less than 1. I get 0.64, which is less than 1. So I select do nothing. And so the next comparison will be do nothing versus the valley site, the much bigger site. So first I'm going to get the annual worth of the benefits of the valley site minus do nothing, which is just going to be zeros again. But so we're just going to look at the annual worth of the valley site benefits. Well, this one has 890 million gallons a year, so this is going to be 890, lots of zeros, and this is going to be gallons per year times $3 per 1,000 gallons. And we will delete the gallons. We'll cross out this 1,000 with that last 3 zeros, and we'll get 3 times $890,000 per year. Okay, so when we do that, we get $2,670,000 per year, and of course that's still years 1 through 20. And now we need to get the annual cost of the valley site minus do nothing. Well, we're just going to work with the annual cost of the valley site first. I mean, we could subtract 0 there. Okay, so the annual cost of the valley site, well, the valley site cost $11 million to build and $400,000 a year to operate. So this will be 11 million times A given P, 8% for 20 years. This will give me dollars per year plus $400,000 per year. And so when I do this, I get 1,520,374 plus 400,000. I'm sorry. This is a 112. I had already added it. 1,120,374 plus 400,000 will give me 1,520,374. So now to get my delta BC of the valley site minus do nothing, I'll get the benefits of basically the annual worth of the benefits of the valley site minus the annual worth of the benefits of do nothing, which is 0, divided by the annual worth of the valley site's cost minus the annual worth of the valley of the do nothing cost, which is also 0. So that's just going to be 2,670,000. That's the benefits of the valley site. And then the cost is 1,520,374. Of course, you can see that's greater than 0. In fact, I get 1.76. I'm sorry, greater than 1.76, which is greater than 1. So we select the valley site, and that's our answer. I also have the answer to this one typed out here, and I will include that in the notes that I post on Blackboard.